Gentlemen, welcome back to the shop. Today we are going to take a new direction. Now normally we take a fully chromulated brand new tool and we fix it until it's broke. Well, this time we're doing it bass-ackwards. We're going to take a broken tool and fix it till it's fixed. These drills are just here for making the proper thumbnail so people clicky on the vid. What we're actually going to do is deflummox the old Cuisinart Mixer. Now, me and the old Cuisinart, we're not good friends because it's one of my wife's tools. The kind of a no-fly zone because I'm a bit of a bull in the china shop in there. But anyway, I was using it and it just kind of broke. So I says to she who must be obeyed, baby sugar, honey, darling, no worries. Given enough time and money, I can fix anything. Just to get her through, I stole her old eye drill here. Gave her this. What for mixing the bread dough and whatnot. She wasn't too happy about this meat hook abortion. She suggested I go down in the shop and take care of something else. I couldn't agree with her more. It's a win-win. So I wanted to point out that this eye drill has a family resplendence with this Milwaukee. Why would that be? Because Milwaukee is actually owned by a Hong Kongese conglomerate that makes Milwaukee, Ryobi, Craftsman, a whole bunch of other crap. And that takeover happened in 2006. They bought it from Alice Crapco, the compressor company, the Swedish compressor company that also makes mining gear. And it seems to me that the brand has been on a steady decline since then. Those whole hogs that used to be indestructible are now absolute junk. Now that's just my quick foreshadowing rant for a future vid in which I lay out a blast of shit, but a little foreshadowing there for you. Let's move on. Now the better half, God bless her, doesn't care for molybdenum disulfide thumbprints on her tools. I don't care, so where are you to, my old knife? Jeezless, my kingdom for a knife. There we go. There we go, most dangerous tool on the claim right there. So normally I would just fix this and I wouldn't tape anything. But the real reason I am is because somebody actually asked me, hey, there's a lot of guys that are super interested in kitchen tools. Like that's their deal is cookery, you know, making bouillabaisse and bolognese and baklava and all that sort of stuff. It's a little fancy for my liking. But I see that these are just tools, the same as workshop tools. These are tools of the trade. So I'm kind of interested to see how these things are made. However, I'm going to try and not devolve into full-on nerdgasm just because I suspect that guys and ladies who are interested, super interested in kitchen gadgets are probably not too interested, for instance, on the minutiae of how they get this amazingly reflective chrome surface on a plastic part. Now obviously they can't use electroplating. Fuck it. I'm going full nerdgasm. This is really a mind-blowing technology how they make this. They surface coat a metallic onto a plastic, and it's really not a very old technology. So the implementation of all this new technology happens so quickly within the span of a decade, and you go from the lab buying components that would cost you $1 million to having millions of these for $1. How they do this, they get a plastic piece super clean. Then they put it in an autoclave, and an autoclave is essentially a pressure cooker, except it's under full vacuum. And then they pump in argon or a shielding gas of some sort, and then they pump it out again. And there's the Goldilocks effect. It can't be fully vacuum. It has to have a few little molecules in there. Otherwise, the next process, the sputtering, won't work because you need some atoms of gas in there in order for this special magnetic magical JFM device shoots plasma at the metal that you want physical vapor deposited on your plastic. So what happens is you have a sputterer. It makes atoms of the chrome billet that you put in there fly off because you're in a vacuum. when those are floating around in the vacuum, if they come across any solid surface like this plastic, they deposit themselves on there. And that is how we managed to get chrome onto plastic, even though the plastic is not possible to electroplate it with, which is a much more established technology, electroplating. Let's get into it and see what we can see. So right off the bat, the construction is problematic. They don't want you in here. So this is all plastic clipped together, one-way check valve. You know, it's never supposed to come apart. Basically, if it breaks, you throw it out. I have a feeling, however, under these little feet are 4 screws. We're going to go for the extraction of the 4 screws and then see what we can pry apart. Yeah, that is just not going to work. As they say in the fancy French restaurants, what we have here is a côte hook abortion. Ho ho! But the wine was delicious. Son of a diddly. Yeah, not so tough now. There was a young girl named Sapphire who succumbed to her lover's desire. She said, "It's a sin. But now that it's in, could you shove it a few inches higher?" Hey, look at this. This is weird. So this is really interesting. It's weird because you'd generally see this in an old style hand tool. And what this is, instead of having copper field windings on both sides of the rotor, this part that spins, they actually only have one field winding, and it goes around this transformer core steel here, and this steel is high magnetic permeability. They load it right full of silicon, the element silicon, in order to reduce the magnetic reluctance. And of course the coil, so we'll have a north pole here, we'll have a south pole here, changing 60 times a second. But this commutation of the rotor spins so fast that it doesn't, this could run on AC or it could run on DC. It doesn't matter. This thing doesn't care. That might come as a surprise to you, but when you think about this, it's got commutation bars so that it changes its own polarity, and it'll probably change its own polarity like 60,000 times a second when it's running. Sorry, I misspoke. 60,000 times a minute. And this is interesting too, kind of crappy. We've got a small ceramic cap, a big plastic cap here, capacitor, and those are to limit the voltage spikes from commutation. When it actually flips over, it breaks contact for a second, and that electricity wants to keep moving, and it makes the voltage spike, and that can damage stuff. So they add these capacitors in here to limit that voltage spike. But and also limit potentially the EMF, the noise, the electrical or the radio interference noise coming off of this. But the problem is they've got these big long leads that act as antennas. So it will be noisy as a ham radio, this thing, but it's got the FCC approval, so it can't be too bad. Surprisingly crusty. And the reason we bought this was because the case was more skookum. It was stiffer and it felt heavier than the KitchenAid. And I see now why it's heavier, because it's got this big behemoth chunk of silicon steel laminations. Now these are cut into shape and then they'll be dipped in an insulating compound. And that's to reduce the hysteresis losses, basically heat losses in the motor. If this were just one big chunk, that would allow these eddy currents to build up, or to form rather, and that builds up heat, and your efficiency goes way down. Now, they don't care about efficiency in something like this, but they do care about cooling. So they would need bigger cooling. That means bigger blah, 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 blah. So laminations are the way to go, and that's why they do it. Right, we got the quick release mechanism off here for the beaters, so we'll just take a look at its electrical circuit board, and it's surprisingly crusty. I can see here this is a voltage divider, so here's an IC chip, and I looked this up. It's an Atmel actually, U208, which is low cost trigger for this triac. Now what the triac is doing is it's essentially a switch. It's turning off and on, and this little guy is controlling this when it turns off and on. When it turns on, the beater goes. When it turns off, the beater stop, right? Only it's smarter than that It's also got current sense, and it's designed to be used with real crusty power supplies. Of course, this little chip can't handle 120 volts. This guy can. So in order to get the, say, 5 volts that it needs to run DC, we have a voltage divider, crusty way to do it, and a little diode feeding it. So this will reduce in between these two resistors. There'll be 5 volts, so there'll be, say, 20 volts that drop off, or 120 volts that drop off on this resistor, and only 5 volts that drop off on this one. We put that through a diode to feed this chip. Super crusty way to do it, but the chip is designed to handle it. And it's also interesting because it's got soft start and current sensing. So if it senses that it's over torque, like the motor is drawing too much current, it can reduce amount that this is triggered off and on, because this triggers off and on very quickly, and it can reduce the current to the motor so nothing gets damaged. And it can also, when you first start a motor up, there's no load there, there's no impedance to the electricity, so it forces its way in there. You get a huge amount of current that can fry some other stuff. So what they do is they use this IC to slowly start the motor. It's called a soft start. So that's an interesting little IC, but the rest of this is real crusty, like definitely built down to a price, as cheaply as possible. Now if you have a tool, and this is a tool that's gone south on you, and you want to try and have a go at fixing it, the first thing to look at is the trigger, of course, because it's between the steering wheel and the driver's seat. It always craps out, so you have a look at that. And then if you have a feeling it's electrical, you don't need to be a rocket surgeon to have a look at this, because you'll see where something's been burnt, and then you go ahead and take the numbers off it. You can order those parts for a couple bucks and just replace them and see if that works. I mean, for instance, this Cuisinart is probably a $120 tool. Now, am I going to throw it away for the sake of a 20-cent capacitor here? All this other stuff, these are just passives here. We got an MOV, a metal oxide varistor, and that's again just to reduce noise. We've got a couple of power resistors. This looks like an inductor. We got some diodes here, all sorts of passive stuff, and these are all just candy store easy parts like Lego bricks, no big deal. So if you can find where and what let the smoke out and replace it, you're golden. Put it this way, if it's already fucked, there's no harm in taking it apart, because you're not gonna fuck it any more than it already is. So you might as well have a go at it at least, instead of chucking it in the landfill. Okay, so what we got happening here is we got two little tiny bearings on this rotor shaft, the motor rotor shaft. So that IC controls this switch, the triac, which turns off and on the AC, the power to this rotor. And then we have power going into the field winding. When we have power to both, this will start to turn, and the commutation will make it switch poles, so it'll continue to turn. The bearings hold it steady, and then on the end here we have a worm shaft, and I'll focus in on that. Here we have the fan. It's a metal fan. You can see the motor rotor turning. This is a worm shaft, and we have these wheels turning. So this will be a deep reduction. There'll be a high reduction, so it takes a lot of turns of this motor to get this wheel to turn, which in turn is indexed to the beater. So the beater's locked in there. That's how the motor can turn the beaters. So if you look at this worm shaft, it's a two-start worm shaft, and essentially it's a real coarse stud. I got a stud here. Well, we got two studs here, and essentially all that's happening is we're turning this bolt, and these wheels are getting threaded into the bolt, but they're not actually a nut, so it makes them turn. We'll make a mark, as I said. We can do it up here as well, and we'll make a mark on the fan. That's a TDC, top dead center. Well, close enough for the girls I go out with. Now we're just going to turn this motor rotor and count how many times it takes for this motor rotor to turn for one turn of the wheel. So that's one. So between 21 and 22, so we'll say it's 21 and a half to 1. So The motor rotor needs to turn 21.5 times in order to get the beater to turn once. And just getting back to this worm shaft here, it's got a 2 start. So if you look at any bolt, if you turn it 100 or 360 degrees, there's only one start in that 360 degrees. So a 2 start would have, it's essentially 2 separate threads, and it's they're 180 degrees apart from each other. That changes the gear ratio, but I promise not to get into nerdgasm mode, so we'll just leave that for another time. I see something here that just makes me shake my head, and I see how low quality and low duty these kitchen gadgets are made. They're not even close to the quality of, say, a hand drill. If you look at this, here's the preload spring for the brush. The brush is a carbon brush that conducts electricity, and it actually drags on the commutator of the rotor. It needs to actually touch that so that the electrons can get into this winding in the rotor and actually make the thing turn. But these things get hot, and this is the brush holder assembly itself is just plastic, cheap chintzy plastic. So if you use this for any amount of time, it would melt away unless, well, I guess that's why we have that soft start IC and all that stuff in there to monitor the current to make sure it doesn't get too hot. But there is no temperature monitoring anywhere on here. So conceivably, you could quite easily melt these brushes right out of there, and your machine would no longer chooch. At the first of the vid, I kind of led you astray there because I actually know what's wrong with this, because I'm the great lummox that made it wrong. I didn't see that there's a little pictogram here, a barely visible pictogram, that these have to go in the right hole. They're different. See, this one's got an index bar here, and this one has none. Who knew? I mean, at first blush, these look pretty much the same. So what I did was I jammed the wrong one in the wrong hole, and so it looks like I done fucked her good and proper. There's one of the 2 little tabs that hold in, that retain the beater, and they're broken clean off. And no fixing that. Well, you don't want to have the beater falling out. That's enough to drive your poor dear sweet wife to drinking, if just being with you isn't enough. Okay, I'm going to go on the gargler, see if I can get this little plastic choochy bit here, and in the interim we're going to fill that hole full of chili con carne and let it chooch, see if we can get it to retain that way. Save ourselves a couple of shekels. Okay, I just got the silicon carne blue. It's safe for sensors, so likely the curing agent in there isn't too votive. What for came the silicon carne, you ask? Well, I figure once it flummoxes here, it rigidifies, and then, but not too rigid, and you'll be able to stick in the pokey bit here, and hopefully it'll retain it and not ruin my wife's cherry's jubilee, if you're rolling what I'm smoking. Anyway, this will take a few hours to chooch, so the wife just came in and told me, well, I heard Elmo just cranked on the old TV, and my wife came down and told me she was ready for a glass of drink, so I think it's about time. I bid you hasta mañana and hope you enjoy this brief intermission.
Welcome to Exploding Record Roulette. If you saw us last time, you saw our slow motion camera mount come loose and the footage went all wonky in hell. So we're trying some free hanging pendulums here to see if we can clear up some of that vibration. In the arena, we've got Luscious Lori. She's ready for a come to Jesus moment from our gospel platter. We've got Blinky, the alarm clock you can no longer set time. Now, I have been getting hate spammed by the hipsters again for blowing up that Minolta. So, in honor of everybody who has a neck beard and flannel, I've got the Discovery perfectly functional classic camera, which was awesome. It worked great when I blew it up the first time. I've also got my craptacular meter there, and then don't ask, don't tell G.I. Joe. He's, recovering from his fresh hip dislocation there in the corner. The Come to Jesus record, you can actually see the crack reflecting in the light there. I have no idea how long or how well she's going to hold together. If we don't get the response we want, then damn it, I'll blow another one. Exploding Record Roulette.
And we're back. Got her stiffened up nicely. Now hopefully I haven't broken too many shitty plastic tabs on the way in, so that we can enrobe this and give her a try. Man, this thing is crusty. There's no spare parts whatsoever. The only thing you can buy are the beaters and a spatula, I guess, for the bowl. Yeah, just pretty endemic here, this throwaway mentality. I myself, you can't buy a good hand mixer, can you? Maybe a Hobart or something like that, like a industrial one. I doubt it. It's a race to the bottom. He who finishes firstest with the brownest nose wins. I'm sure some of you gentlemen have worked places like that. I know I have. And that plastique is all stripped right out. Oh fuck. Every which way but sideways. I looked for a injection mold mark to see what kind of plastic this is. I couldn't even find one. There's nothing on there. It is shitty, and it's that plastic. It's probably got the bromide in it, so it'll turn all orange on you, nicotine orange, after a few years. So you got to throw it out, even if it's still working. Son of a diddly. Well, let's give her a try, shall we? Oh yeah, that turns pretty fast. Oops. Well, I'd call that a rousing success. Well, for once we went with the prime directive. If it ain't broke, don't fix it. And as you can see, didn't turn out too well for us. Unfortunately, we still had a failure to chooch. In any case, we had fun looking at some crusty old cheap consumer goods. Makes you wonder. Makes you wonder. Actually, makes you sad. Well, there you have it. There's the linchpins of the whole operation. I done murderlated them, bustimacated them off, and the whole thing is, as the Scandahoovians say, a yunk. Well, you guys know that given enough time and money, we can fix anything. And when I don't fix something, well, god damn it, it hurts me right in the hubris. So we're gonna see how much plastic it took. Holy 0.05 of a gram of plastic disabled this entire, Jesus Christ, unbelievable, shameful really. Now let's never speak of this again. I might just have a few more portions of liquid counsel here, have a set and a think about this. Maybe I'll figure out another way. Thanks a lot for watching. Keep your stick on the ice.